Now, what can we do with more than two lanterns as a signaling mechanism? In this case, just to be a bit humorous about it, and to make for a different situation, I decided to use M&Ms, yellow ones and blue ones. So these could represent lanterns, or these could represent electrical charges that are either on or off, or magnetized spots, which are either with a north polarity or a south polarity. Anything that can represent two different conditions unambiguously could be used to store this kind of information. And here we have 3 bits. So you can see if we track through all the different possibilities, we could have everything yellow, or 2 yellow, 1 blue. The position of the blue moves to here, 2 blues, 1 yellow, and finally 1 blue, 2 yellows, and the remaining combinations. And this completely exhausts all the possibilities from all yellow through all blue. So it's binary meaning each of these bits can be in only one of 2 conditions. And when we map them out this way, we can count and see that there are 8 possible conditions, which of course follows the rule that I mentioned on page 10. 2 states here possible, 2 states here possible, 2 states here possible, 2 times 2 times 2 is 8, which is the number of different possibilities. We can also represent that by saying 2 to the 3rd power. That is 2 here with a little exponent, a superscript of 3. So we say this is 2 cubed. Now you can see by extending this mechanism for finding out how many different possible combinations there are with a given number of bits, what it really comes down to is 2, because the bits we're using are binary. They're only going to be in one of 2 different conditions. That's why we can always say 2 times 2 times 2 times 2 as many times for the bits that we have, or we can just say in the number of bits becomes the exponent, and 2 is the number that's being raised to a power. So if I had 4 bits, how many possibilities would I have? 2 to the 4th power, 16 combinations. Now the question is, as posed here, how many M&Ms in this case would we need to use to have enough combinations to represent all of the letters and numbers and punctuation symbols we need to represent the English language? If we can achieve that, then we can code every character or punctuation mark or number symbol with a particular bit pattern.